This is the video for Mod 11 Lesson 3A, Graphing Equations of Circles. In this lesson, we're going to be looking at graphs of circles. So we're going to be looking at graphing a circle with the radius and the center, writing the equation of a circle given a center and a radius, and finally writing an equation of a circle given a center and a point. So the theme of this section and the next section is going to be graphing circles on the coordinate plane. And we're going to see some of the same things we saw with graphing quadratics in vertex form. We're going to see H and K. H and K is going to represent the center of our circle. And then we're also going to end up seeing R for radius. So our equation for the circle we're going to see is x minus h squared and y minus k squared equals r squared. In this first example, we're going to graph the equation of our circle, and we're going to again use our standard form. So our standard form is x minus h squared plus y minus k squared equals r squared, where hk is going to be our center. So very similar to how we saw in quadratics, the subtraction sign is actually part of the formula. So when we're finding like our center, the x coordinate for our center, we're going to take the opposite sign. So our center, the opposite of -1 is +1, right? And it's like we're setting that parenthesis to 0. That's why we're taking that opposite sign. Then we see a +3, so the opposite would be -3. So our center for our circle is actually going to be at 1, -3. So I'm going to mark my center. We then have to put our radius. So remember, our radius for the formula says r squared. So our radius actually isn't 4. We have to do the square root of 4. And that's going to give us 2. Sometimes our radius won't be, or r squared won't be a perfect square, and that's okay. For graphing purposes, we like to usually use the decimal because it's easier to figure out where that is on the coordinate plane. And so what we're going to do is we're going to plot points that are 2 units away from the center, but we're going to pick the vertical, going vertically and horizontally. So we don't want to go diagonally. So if I start at my center and I go 2 units up, and then I go 2 units to the right, 2 units to the left, and then 2 units down, I actually have here 4 points, and I'm going to do my best to now plot a circle that hits all 4 of those points. So notice I'm not making it look like a diamond, I'm making it look like a circle that hits all of those points. And then that would be the equation of my circle. So I plot 4 points, up, down, left, right, and then connect it to make a circle. The next example is pretty much done the same way. So for my center, I'm going to take the opposite of 4, so that's a -4. My y, I don't see anything there, and that's the same as a y minus 0 squared. So the y coordinate's is 0 because I don't see anything there. And then my radius isn't 10, it's actually the square root of 10. Which if you put in your calculator is roughly about 3.1 units. And decimal, it's okay to have a decimal or a radical. It doesn't have to exactly be an integer. We're just going to kind of estimate where that is. So if I plot my, my circle, my center's at -4, 0, so I'm going to plot my center. And then I'm going to go roughly about 3.1 units. So 1, 2, 3, I'm going to be a little above the 3. Do 1, 2, 3. We got one here. And then 1, 2, 3. And then 1, 2, 3. And then just do my best to try to create a circle. And again, it's just a sketch, but we can kind of see it's trying to go through those 4 points we just plotted. In the next example, we're given the center and the radius, and we have to write the equation. So for example 1 and 2, it's going to look really similar. Just one of them has a radical, but same concept. So if, again, we have our standard form, so x minus h squared, y minus k squared, r squared, and then we have centers hk, and this is my r, hk, and this is my r, and then you're just substituting it into the formula. Remembering the subtraction is part of the formula. So if it's positive 1, it's written as x minus 1. If it's negative 6, it's written as xy plus 6. And then 12 squared is 12 squared is going to be 144. And then this would be my equation. The second one, same idea. So my h is negative 4, so I'm going to write x plus 4. My k is 0, so I don't have to write y minus 0. I can just write y squared. And then I'm squaring 2 radical 3. So in your calculator, you want to make sure you put a parenthesis around the 2 radical 3, not just squaring that radical 3. And so we would get x plus 4 squared plus y squared equals 12. And that would be our equation. For this last example, we still have our standard form. So we have x minus h squared, y minus k squared equals r squared. They tell us the center, so we have our h and our k, and the point that it passes through, we're going to treat that as x and y. So when we put that into our formula, we're going to have negative 11 minus negative 8, so that's going to be plus 8 squared. 5, the opposite of positive 9 is negative 9 squared equals r squared. And then we're going to go ahead and simplify. So we get negative 3 squared plus negative 4 squared equals r squared. That's 9 plus 16 is r squared. And then if I wanted to find the radius, I could leave it as r squared because that's really all we needed for the formula, but we do get the radius to be 5. And so when we do now our equation, I have my center, so x plus 8 squared, y minus 9 squared, and I already know what my r squared is. R squared, we said, was 25. And that would be my final answer. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.